at Rewild. While everyone is jumping in here, I'm going to go ahead and start our lovely video.
You just hit the side arrow.
This is the moment when a team in Papua New Guinea found a long-lost bird.
Doka. What is this? It's owl.
That is the joy of finding an animal lost to science for more than 100 years. Welcome to Rewild's search for lost species, which scours the planet for animals, plants, and fungi that scientists feared lost for at least a decade. The search for lost species has found more than a dozen of our most wanted and documented many rare ones along the way, like the Volkscow's chameleon, Fagild's trapdoor spider.
It's more important than holding a treasure. For me, it was more valuable to hold that spider than any other object that I ever held in my life.
Attenborough's long-beaked echidna, the Somali sengi, the big puma fungus.
Fue una alegría inmensa de compartir esta alegría con las personas de la comunidad.
And this little nugget. It's the world's most crucial game of lost and found, given that an estimated 1 million species are at risk of extinction by 2050. Our goal is to reverse that. Finding a species is just the beginning. Each rediscovery leads to media coverage reaching billions, capturing our imaginations, raising awareness.
Get it, Doc. Can't we just save them for fashion?
Contributing crucial knowledge, leading to real, tangible conservation on the ground.
Finding the species opens doors for us to pursue habitat protection as well as conservation projects for other species that are also in the same ecosystem.
As our quest continues, you can support us as we search for lost sharks, lost fishes, lost birds, lost amphibians, and more. Because what these rediscoveries teach us is, all is not lost. What is lost can be found. We can protect and restore our planet. Together, let's find something wild for all wild kind.
Man, my legs are shivering. I can't believe it. God.
Thank you for joining us. If you're new to the Lost Species program, that was just a little overview of what we've been doing since 2017. Drop your name, drop where you're from in the comments section so we know who's joining us today. And my name is Christina Biggs. I am the manager of the Lost Species program. I oversee the most wanted list and those taxa-specific lists that we just talked about: sharks, amphibians, birds, and fishes. So we've had 2 webinars so far. You can go and see those on Reverse the Red's YouTube channel. This is the 2nd year that we are partnering with Reverse the Red to talk about lost species. We also have one more coming up after this. But today we're talking about the data that underpins the Lost Species program. And we have 3 amazing panelists with us who have been contributing their knowledge and their time. And we're going to start out with Kelsey Neem. Kelsey is my coworker here at Rewild. She is our species priorities and metrics coordinator. She is committed to using this data to enact meaningful and impactful conservation action. And since 2015, Kelsey has served as a program officer at the IUCN SSC Amphibian Red List Authority. So she leads the extinction risk assessments for the world's 8,000 plus amphibians. She has also been absolutely key to helping me work on a global program for lost species. So I'm going to turn it over to Kelsey now.
Thanks, Christina. Really glad to be here with this wonderful group today. Good morning, good afternoon, and good evening, wherever you're joining from. It's an honor to be here presenting today about the data underlying the search for lost species. and how we analyze and visualize those data to help prioritize efforts to locate the world's unseen, unfound, and unknown species. Ultimately, the goal of this work is not only to find these species, but also to leverage the discoveries to guide broader conservation actions and policies. So let's dive in to these data-driven approaches that support this important work. It sounds like there's probably a lot of people who are fans of the Lost Species campaign here today, but there might be some who aren't familiar with what a lost species actually is. So for those of you who aren't quite sure, let's start with a quick overview or a refresher. The search for a lost species considers a species to be lost if it has not been scientifically documented for at least 10 years. And it's not held in captivity, so that includes zoos, aquaria, or breeding programs. Lost species can be in any category on the IUCN Red List of threatened species, except those that are extinct or extinct in the wild. And species can become lost for a variety of reasons. In some cases, species that once existed as healthy populations are now possibly extinct due to a variety of threats, from habitat loss to disease, poaching, the effects of climate change. There's other cases where scientists actually just haven't been able to access certain areas because they're just difficult to reach, or they're conflict-ridden zones. There are also cases of species just being very naturally rare to begin with, or incredibly cryptic, so difficult to find and really difficult to detect or monitor. The list of lost species is a living list, so this means it is regularly updated as we get new information. This allows us to stay really informed about the status of these species and keep it up to date. And ultimately, we can't save what we don't know. So understanding and documenting these lost species is crucial for our conservation efforts. Working with hundreds of experts across IUCN Species Survival Commission specialist groups, as well as other institutional partners, Rewild recently updated and expanded the list of lost species to approximately 4,500 species across more than 200 countries and territories. The process of curating this list starts with nominations. So as I mentioned, the IUCN SSC specialist groups, along with many other experts who aren't members, play a really crucial role in identifying the species that meet the criteria for being considered lost. Their expertise helps ensure that we have the most suitable candidate species included. And then once these species are nominated, there's a verification process to ensure that they actually do meet the loss criteria. So again, that they were lost for at least 10 years and that they are not held in captivity. And then, of course, maintaining the list is really this ongoing task. It requires a lot of effort and resources to keep it up to date. We need to regularly update this list to reflect any changes in species taxonomy, as well as rediscoveries, which is very exciting. So species that were previously thought to be lost are removed from the list. And then we'll also remove and update once any species are declared or confirmed extinct. These updates help us keep the list accurate and relevant for planning and prioritization efforts. Let's take a moment to look at one of the IUCN specialist groups, the Amphibian specialist group, of which I'm a part of, that played a pivotal role in the lost species work from the very beginning. So in 2010, Conservation International launched the Search for Lost Frogs campaign with support from Global Wildlife Conservation. This campaign was the brainchild of Rewild's very own Dr. Robin Moore and his colleagues, who were really alarmed by the findings of the Global Amphibian Assessment in 2008. and wanted a way to raise awareness about the plight of these really highly threatened animals. At the time, the Search for Lost Frogs list included about 100 amphibian species. Fast forward to 2017, when Rewild launched the search for lost species. By this point, the list of lost amphibians had grown to about 240 species. And then with the publication of the second global amphibian assessment last year, the amphibian specialist group used these data, updated data from the extinction risk assessments for over 8,000 amphibian species. And we revised the list of lost amphibians, which is now more than doubled the number it was in 2010. Once we compile the data and we update the main lost species list, we can start to analyze it and visualize the data to examine patterns within it. Here we can see that about 3/4 of the list is made up of reptiles, fishes, including sharks, plants, and amphibians. Among vertebrates, we see mammals and birds a little bit lower on the list in terms of representation. This could be a variety of reasons, but generally because they're better studied and receive comparatively more research attention. It's really important to note, however, that we have a long way to go, I think, in terms of adequately populating the lost species list with some of the lesser known and overlooked taxa. So things like invertebrate groups and fungi. As we start to gather more and more data on these taxa, we can expect the percentages and their representation to increase in the future. We can also analyze factors like threat status on the IUCN Red List and the geographic spread of lost species. So when we look at threat status across all lost species, you'll notice quite a significant proportion of these species are classified as data deficient and critically endangered, possibly extinct. And when you think of a lost species, this actually makes sense. These categories on the Red List include species that we either know very little about or those that could already be extinct. In terms of geographic distribution, the highest proportion of lost species tend to be found on islands, many of which are the single island endemic species. And we also are seeing high representation in South America, continent known for its incredible biodiversity. These patterns might point to kind of the vulnerability of island ecosystems, as well as the conservation challenges in biodiversity hotspots, such as those in South America. Using the data, we can also look at things like how long have lost species generally been lost? Most of the species we're seeing on this list have been lost since 1970. Really underscoring the urgency of our exploration efforts and reinforcing the importance, understanding factors contributing to the species becoming lost in the first place. We're also seeing about 1/5 of the species on the list that have been missing for more than 100 years. At first glance, it might seem like there's no hope in finding these species. They've been long lost. They've been lost for almost a century. But let's not forget some of incredible rediscoveries just within the last year of species that have been lost to science for more than a century. These species offer us hope and really serve as a reminder that with persistence and attention and improved search strategies and advanced technologies, there's still a chance to find and protect these species before they're lost forever. We have used the data on the lost species list to produce a global hotspot map for all lost species where spatial data are available. So that's about 80% of those 4,500 species currently on the list. And perhaps not surprisingly, and something I've already mentioned, is that the map is showing us hotspots of lost species concentrated in the tropics and on islands, both areas known for their high biodiversity and unique ecosystems. And with so many species on the list, we have thousands. It's clear we can't just go one by one and on expeditions and try to find them. We'll potentially lose these species before we can find them. So we need to be more strategic in our search efforts. And one way to do this is to prioritize searches that target areas that contain or home to multiple species and where they're likely to be found. And so this global richness map is one way that can help us pinpoint these hotspots of lost species and identify key candidate areas for future searches. Earlier this year, the Lost Species Program hosted a series of workshops with local students and researchers in Kenya, Uganda, the Democratic Republic of Congo, and Tanzania. And the goal here of these workshops was to identify lost species that were not currently on the list and update the list, as well as collaboratively develop proposals to go on expeditions. And so these country level hotspot maps of the lost species richness, like the ones shown here, were really kind of a key component of informing these priority areas for expeditions. So we use these maps to either look at lost taxa collectively across the country, or we could focus on specific species groups to really ensure that efforts are strategically targeted. So come join the search. We're asking for folks we're calling on everyone to join this campaign and to join the search for lost species. There's a variety of ways you can get involved. One of them is to help us update the list. You can check out the current list. It's, again, a living list, so it's pretty much constantly changing. And you can find it at this website here. And let us know if you have species to add, you know of any of rediscoveries, or you have any changes to suggest to the list. We are all ears and we really welcome your input. You can also get out into the fields on your own journey, on your own quest to search for lost species. And please report your observations either to us directly or on our iNaturalist page. We are continuing at Rewild to collaborate with teams who are going on expeditions and individuals as well worldwide to publicize their stories of rediscovery. So please get in contact with us, as well as publicizing your own stories and sharing other people's stories of rediscoveries. Every story really adds to the momentum and inspires others to get involved. So I mentioned the iNaturalist page for our lost species work. If you haven't visited the page already, I really encourage you to do so. There's the QR code here on this slide. And just become a member of the group, even if you want to stand by and watch what's going on. We'd love to have you. And the iNaturalist community so far is already playing a really important role in this effort by reporting the rediscovery of handfuls of species. So with that, I think I'll turn it over to my other co-panelists to talk a bit about their lost species work and their data-driven insights. Thanks so much, and I'll be more than happy to answer some questions if there's time at the end of the webinar.
Thank you, Kelsey. That was awesome. I actually learned that's the first time I was seeing that lost species richness map, which Kelsey has been spending endless hours gathering that GIS spatial data. But as she was saying, looking for lost species, going one by one isn't practical when your list is 4,500 species deep. So we've been looking where we can overlay things, and those Africa Geographic regional search, those maps were So valuable. So thanks, Kelsey. Now we're gonna pivot to sharks. So let me introduce Eric Snyder. Eric works for Cape Eleuthera Institute, where he was just recently promoted to assistant director. He has been focusing on sustainable fisheries and conservation marine biology, but he is also a member of the IUCN SSC Shark Specialist Group, and Eric has been working tirelessly over the last year as we got ready to launch our Search for Lost Sharks initiative, which just was announced on October 1st. So Eric, tell us more about developing that Lost Sharks list.
Yeah, thanks, Christina. Can you see my first slide all right?
Mm-hmm.
Okay, great. Hi, everybody. So my name is Eric. I am the Assistant Director of the Cape Eleuthera Institute in the Bahamas. I am primarily a fisheries biologist, and I'm really excited to be collaborating on this work. And I'm going to be talking a little bit about the process that we used to put the list of lost sharks together. So I started out with this title of how to find lost sharks, but I think more appropriate is how to find which sharks are lost. So that's what I'm going to be going into. So the lost sharks list is a little bit easier to say, but it actually encompasses all cartilaginous fish in this class, Chondrichthyes. So that's sharks, rays, and chimeras. And just for ease and continuity, I'm just going to call it the lost sharks list or sharks, but it will encompass all of their close relatives there as well. So sharks and their cousins are a more reasonably sized group for a sort of manual investigation as compared to some others. So there are just under 1,200 species of sharks, rays, and chimeras in the world. About 45% of those are sharks, about 50% are rays, and about 5% are chimeras. If you're unfamiliar with that last one, they're also known as ghost sharks or ratfish. So here's a nice example of the Bahamas ghost shark, which is a chimera that's actually on the lost species list, was last seen in 1974. So again, comparing a taxonomic group of this size, just over 1,000 species, to something, let's say, for instance, all freshwater fish, which is about 18,000 species, which wouldn't really be feasible to just go through one by one to do a literature search to figure out if we've scientifically interacted with these species over the last 10 years. With sharks, we could, and that's what we did. And so just as a reminder, the rewild definition there is lost shark was not documented by science in at least 10 or more years. So to compile this list initially, a colleague and I, Kieran Hyde, first started with primary data sources. So we looked through scientific papers first to look for studies that have been published and peer-reviewed on all these species of sharks. If we didn't find something within the last 10 years that specifically mentioned an interaction with the species, we expanded our search a little bit to what's called the gray literature. So these are still things that are published, but maybe not peer-reviewed. So things like some government reports, fisheries reports, or landings data. Landings just meaning anything that a certain fishery catches. And then if we still couldn't find anything for a given species in there, then we would also extend our search out into popular press and social media or things like iNaturalist, more to direct our kind of thinking and our search to see if we didn't find anything in the first two types of sources, is anything out there about a given species. So that's kind of the process that we used. And we essentially went through all of those 1,260 or so species and tried to figure out if there had been anything documented by science in the last 10 years. So the initial thing that we were interested in is how many of these species are actually lost. And I'll kind of switch it there to start with the not lost. So about 65% of sharks, rays, and chimeras are not lost, which is great. One example, just one of my favorite sharks here, is the silky shark. This is very commonly caught, very commonly seen. This one exists in all of the world's tropical oceans. And then conversely, about 34%, or about a third of all of these species, are lost, meaning that 425 species of sharks, rays, and chimeras have not been scientifically documented in at least the last 10 years. One example is this shark that you see on the bottom of the screen. that is called the lost shark. Its common name is now lost shark, or Carcharodontis obsoletus. This one was last seen in Vietnam about 90 years ago, and is also on this sort of priority list for searching for. So this pie chart here just again gives you an idea. About 2/3 of all shark, ray, and chimera species are not lost, but about 1/3 of them are. And as mentioned, these maps can be really helpful in sort of directing some of our search efforts, but also just trying to get an understanding of, what are the distribution of lost sharks. So again, my colleague Kieran Hyde made this great sort of heat map here. So the scale is just there on the bottom left, where you can see dark red shading is ranges or areas that these animals live. That has 50 or more lost shark species in an area. And then as you sort of get lighter red, that's less and less species in that area. And we see a couple interesting sort of hotspots that come out here. So in the blue circle right here, the Caribbean has a lot of these lost shark species, as well as in Southeast Asia and around Australia and New Zealand. So again, similarly fitting into that theme of some of these islands, also in the water, are the areas where a lot of lost species occur. So from there, it was a really interesting process as we were looking through and compiling this list initially, to think about this question of, well, are lost species actually endangered? Or maybe not endangered is the wrong word to use there, but endangered or imperiled. It would seem so, right? But that's not necessarily the case. So on the left side here, if we look at just this pie chart of all the not lost sharks, so the ones that we have interacted with over the last 10 years, these are the different designations of extinction risk through the IUCN Red List. And it's a pretty even split, about 1/3 of them are least concern. So that's a lot of the common species that we're not too worried about their conservation status. And then sort of roughly equal parts of sort of the more increasingly threatened species. But if you look over on the right side, these are all of the lost sharks and rays. And what's really interesting that jumped out to us is, first of all, over half of these species are in the least concern on the red list assessments, meaning when they were assessed, there wasn't really any reason to be particularly worried about that species being at risk of extinction. And then the second biggest chunk of this pie chart is the data deficient species, which basically meant in most cases, we really just don't know enough about that species or interact with them enough to really be able to make an assessment on whether they are threatened with extinction or not. So the takeaway that I got from that is that, over 3/4 of all the lost shark species are either least concern or data deficient. Maybe they're not actually of really high conservation priority. And we can kind of, again, dig into that a little more to sort of direct some of these activities. So another thing that we found is a lot of these species, just to go back here, in the data deficient and least concern categories, actually live in the deep sea. So I really like this photo here. It's a good reminder. This is most of the Pacific Ocean, just one angle of planet Earth where you can almost see no land. So the ocean covers 71% of the Earth's surface. And of that, 93% of the world's oceans is considered deep sea, which is deeper than 200 meters, or about 650 feet deep. And when we looked into this, about 23% of all the lost shark species are actually deep sea. They actually live in this habitat. That's about 97 species. Now, in some cases, that can actually give some of these species some refuge or some protection. Most of the threats to sharks and rays worldwide come from fisheries. And while there are increasingly more and more fisheries that target deep water species or are moving into deeper waters for various reasons, including exploitation or overexploitation of shallower water species, there's a lot of deep sea out there that might be some protection just because of depth and sort of difficulty of access for a lot of these lost species. Not all. Certainly some deep sea species are still threatened, but it's interesting. So yeah, almost 1/4 of all the lost sharks are deep sea species. So that also brings us to the kind of last point of, a lot of these species were lost to science, but might have only actually been known from maybe one or a couple of different incidences. So it's pretty common, especially for deep sea sharks, other types of deep sea fish. There would either be a trawl, so a big net pulled either by some fishing boat or by research crews that maybe scooped up one individual of this new type of deep sea shark. And it was pretty frequent, and we saw this during our search, that these species would get described. Sort of a publication would come out describing this new species and where it was captured. But then in a lot of cases, that was the only time that we've interacted with that specific species. Again, if this is a research cruise in a remote part of the deep sea that might not really interact with fisheries much. So also a lot of these sort of lost sharks, might not be necessarily imperiled because we might have just found them once, never really looked in the same place again, but maybe there's not fisheries in there. So again, the whole kind of goal of this, putting this list together is directing conservation efforts, and the sort of insights that we gained through the process of doing the search and what we were finding sort of led us to this sort of summary here, where we think it's probably best effort to put our searches and put our efforts towards lost sharks, but ones that live in areas with high human use. So where those species might be imperiled, but still hiding out or just sort of in at some risk there. So typically those higher use areas are going to be closer to the coast in slightly shallower water, where there's going to be more human activity, more chances to find it, but we're still not seeing those. Whereas if you just want to look for lost sharks in the deep sea, you might find them, but you might have time better spent if you're looking in more coastal habitats. So a couple of examples on sort of the priority list that we've pulled from this lost sharks list. Again, this the lost shark, which was last seen about 90 years ago in Vietnam. The Pondicherry shark, which was last seen in 1979 in India, and the Indonesia angel shark, which was last seen about 20 years ago. So hopefully that provides a little bit of context just into the process, putting a list like this together for a slightly smaller group of animals, a slightly smaller taxonomic group, and just kind of guiding our processes on finding out which sharks are lost and then which ones to look for. And so the next section of the webinar today will be focused on some of the rediscoveries of some lost species. So thank you all for your time.
Awesome. Thank you, Eric. Lots of insights. Like you were saying, I wouldn't say it was easy. It was a tough job, and I know how long it took him. But sharks and rays and chimeras being less dense than, say, freshwater fishes, which has 18,000 described species. So it was an interesting case test for us to see how we could do this. As Kelsey was saying earlier, we know that things like invertebrates are really underpopulated on the overall lost species list. So the sharks was a great test case, and also a popular subject. So now we're moving on to Lauren. Lauren Schmuck is a wildlife biologist at the Government of Canada, and she focuses on polar bears. However, she tuned in last year to our Lost Species webinars and reached out to me asking if there was anything she could do to help. And she is interested in rare and cryptic species and is also a data genius. So I found some things for her to do, and she's going to talk about them now. Go ahead, Lauren.
Great. Thanks, Christina. And hi, everyone. I'm really pleased to have the opportunity to talk to you today about a volunteer project that I worked on from November of last year to July of this year. So I'll start just by telling you a little bit of an overview of the project. As you may have heard from some of the lost species talks earlier this month, the list of lost species currently contains well over 4,000 species. This list is not a static list. Species are added as they become lost and as they're nominated for the list, and species are also removed as they are either rediscovered, which is the happier outcome, or they're determined to be extinct. So the project that I did involved further investigating the purported rediscoveries of approximately 250 lost species. The main resources that I used to complete this project included the IUCN Red List, Google, Google Scholar, articles written by various media outlets, GBIF, iNaturalist, relevant scientific papers, and other sources too. So when I looked into each of these purported rediscoveries, each of those 250 species seemed to fall into one of four categories. Category 1 was species that had indeed been rediscovered, and prior to being rediscovered, when they were a lost species, they met Rewild's criteria to be considered a lost species. And just as a reminder, those criteria are illustrated on the left side of the screen. So not observed for a minimum of 10 years and no ex situ population outside the wild. The second group of species had been rediscovered, but there was something about them that didn't meet those criteria I just described. So maybe they were lost for 5 years, say, instead of the minimum of 10. The third group of species had also been rediscovered, but there was some questionable aspect related to their rediscovery. So, maybe the evidence supporting the rediscovery was very weak and not verified by experts. Finally, the fourth category, these species hadn't actually been rediscovered at all. They may never have been lost in the first place, or maybe they were still lost. So the presentation today is actually going to focus just on this first group here, those that have been rediscovered and meet these rewild lost species criteria. So let's jump in. So I created this slide with the aim of illustrating the global distribution of the species that fell into that first category that I described on the previous slide. I wasn't too surprised by the results. As you can see, the majority of lost and subsequently rediscovered species tend to occur in areas of high biodiversity. Kelsey kind of mentioned that in her talk as well. So like South America was a big one. Tropical islands were also a big one. Areas of lower biodiversity, so North America, Europe, they tended to have fewer lost and rediscovered species. So the previous slide focused on the geography of lost and rediscovered species. This next slide here focuses on the taxonomic distribution of these species. As you can see, reptiles had the highest number of rediscovered species. On my slide here, they appear in yellow, and they were followed really closely by amphibians, which appear in the lighter shade of green. Mammals, birds, and insects were kind of grouped together in the middle, and then unsurprisingly, the less charismatic species, so arachnids, crustaceans, fish, fungi, gastropods, they had the fewest number of rediscoveries associated with them. And I just want to make one important point that this graph only accounts for rediscoveries that were announced through some sort of online source that I happened to come across. So it's entirely possible that this graph doesn't accurately represent the proportion of all lost species in all taxa. So there's quite a lot of information on this slide. Let me break it down a little bit. The slide is intended to show the proportion of rediscovered species in each continent and islands, broken down into 4 50-year increments of how long the species was lost for before it was rediscovered. So I'll note actually that the first 50-year period in the top left here is actually only 40 years because, as I said at the beginning, species lost for fewer than 10 years, we're not counting those for the purpose of this particular project. The red and white do not symbols that you see in Europe and Asia there. They just represent that no rediscovered species that I happen to come across were found in that particular continent during that particular period of time, or that particular 50-year window. So for me, the take-home points for this slide are that the majority of species tended to be lost for between 10 and 50 years. We have our N equals 51. The longer the period of time lost is, the fewer number of species fall into that category. So our first 40 years, we have N is 51. Then we go down to N is 25 for the next 50 years. Next 50 years, we're down to 16. And the last 50 years, we only had 5. So who is going out there and looking for lost species? The answer is anyone can, really. This slide gives examples of species that have been rediscovered by a diverse variety of different people and organizations. There are those whom we would expect to be out actively looking for lost species. So biologists, conservation-focused organizations, universities. Then there are some less obvious ones. So Hydro Tasmania is a great example. Even a charity focused on clearing landmines called the Halo Trust. Local Indigenous and non-Indigenous peoples, and even tourists on vacation in a remote area. In the case of this bird here, the black-browed babbler, it was actually 2 local men, not associated with any particular organization, but they had an interest in bird watching, and they came across this species and took pictures of it and reported their find and sent this picture to local bird watching groups. And after that, it was determined that this species that they'd happened upon had not been seen since the 1840s. So that must have been quite the surprise for them. Here's another example. In the case of the Somali sharp-snouted worm lizard, earlier this year, in fact, a gentleman working for that landmine clearance charity, the Halo Trust that I mentioned, was working in Somalia when he stumbled upon a worm-like lizard. He photographed it. He sent the photo to an expert at Mendel University in Czechia, and it was subsequently determined that this species of worm lizard hadn't been seen since 1931. So the point that I'm trying to make on this slide and the previous slide is that I really hope anyone with an interest in lost species can feel empowered to search in their own backyards or their own countries, their own areas. There are plenty of instances of non-experts finding lost species. And with a list of over 4,000 lost species, there's certainly no shortage of lost species to look for. So let's just spend a couple minutes now talking about the important role of the media in spreading awareness regarding lost and rediscovered species. Many members of the public, they get their science-related news and updates from the media, and this includes news about lost and rediscovered species. So given this, how the media chooses to communicate and portray news about lost and rediscovered species is really important because it can really shape public perceptions. People might form an opinion about how important searching for lost species really is, or how much hope of finding lost species there is, based on how the media chooses to portray these stories. The headlines I came across were generally positive and generally encouraged excitement over the rediscovery of a lost species, which is awesome. There were a couple negative ones out there too. An example of a headline that could be viewed as a bit more on the negative side is seen on the left here. Get ready for nightmares. A tap dancing spider has come back from the dead. This, of course, refers to the rediscovery of Fagild's trapdoor spider. I would also say that the majority of the media articles that I came across tended to focus on the story behind how a rediscovery was made, as opposed to the implications of that rediscovery. This is likely intentional, because I would imagine that the public is probably more interested in a fun story about how something was rediscovered than they would be in, like, what that rediscovery means for conservation. The media also tended to use any unique features of the species in question to really grip the audience's attention. In some cases, almost anthropomorphizing the species. So referring to Fagild's trapdoor spider as a tap dancing spider, or assigning hearing superpowers to De Witten's golden mole. Another observation I made is that when it comes to lost species, the media sometimes fixates on one or two particular species, even if there's a really low probability of actually rediscovering that species. A really, really good example of this is the ivory-billed woodpecker. And we can see a specific headline on the left side of the screen about this. Back from the dead, elusive ivory-billed woodpecker not extinct, researchers say. Whoops, sorry about that. And just a final observation on this slide. I was really pleasantly surprised that it wasn't only the really charismatic species that got media attention. So, for example, the giant millipede that was rediscovered in Madagascar in September of last year, I think all of us can probably agree that that might not be the most fluffy and cuddly of a species. But, I found it received a fair amount of media attention, which I thought was really, really great. And then I'm just going to wrap up my presentation by asking, so who cares? Why does all of this matter? Why would we invest time in documenting rediscoveries? So here are some of my thoughts on why. First, we need to know what has been rediscovered so that those finite resources that exist to go in and look for species are directed towards those that remain lost. Second, some of the purported rediscoveries of lost species really do require a deeper dive to determine their legitimacy. Some species may claim to have been rediscovered in the wild, but maybe there was an ex situ population of these species in captivity all along. Or maybe there was an alleged rediscovery of a species that most experts dispute. That ivory-billed woodpecker I mentioned again is a great example. Third, it's really important to invest time in learning the details of each rediscovery. Just because a species has been rediscovered doesn't mean it's not at risk of extinction. If the population is small enough, the species could easily succumb to the extinction vortex. To avoid this, the species may require immediate conservation attention. And just to further elaborate on this point, one 2011 study that I came across found that 86% of rediscovered birds and mammals, after being rediscovered, continued to remain highly threatened years later. 86%. Fourth, documenting and sharing rediscoveries. It's a really big part of how we celebrate success in the field of lost species. Celebrating success gives us hope, and hope is so important. And finally, documenting information about rediscoveries, it helps inform scientific literature, IUCN Red List status updates, and other authoritative sources in this field. So thanks very much for your attention this morning or this afternoon or this evening, depending on where you are. It was a pleasure to have the opportunity to chat with you about this project. Thank you.
Awesome. Thank you, Lauren. That was amazing. We do have many questions in the Q&A, which we'd like to jump in if our panelists could stay on and answer some of these. I'll start right there at the top. How long do you search before it's called extinct? Have any animals been declared extinct and then found afterward?
I can jump in on this one, and I'm sure others may have something to add. The short answer is that there's really no set amount of time we must search for a species before declaring extinct. It's really looking for a species throughout their entire historic range at appropriate times, so throughout the year usually. And the important thing is that it's over a time frame that's appropriate for the species. So thinking about their generation length, thinking about their life cycle. And it's possible at that point that declaring the species extinct is appropriate. Sometimes it's unanimous among experts, and other times there's debate. Partially because of what you allude to is the Romeo error. So declaring a species extinct when it actually is still out there and it's still alive. So the thing about the IUCN Red List and declaring species extinct is that there's actually an option to put species, list them as critically endangered with a little flag, a little tag that is possibly extinct. And that allows our experts to have more time to do more thorough surveys. Maybe if they haven't done them at the right times of year or for not long enough, before everyone is comfortable and before the data are there to actually allow them to move into extinct. And the other part of your question about whether species have been extinct and then rediscovered, this happens occasionally. There is an amphibian that lives in Latin America that was, I think it was declared extinct in the early 2000s. It basically just disappeared. It was super common and nobody could find it. It had drastically declined, and then lots of surveys had taken place. Folks couldn't find it, and it was declared extinct. Since then, the IUCN Red List has expanded the guidelines for declaring a species extinct, and probably had we had those guidelines, maybe it wouldn't have been declared extinct, but it does happen, but more and more often we are placing species and possibly extinct until we really have that information, and are more comfortable declaring extinct.
Yeah, and I think talking to that, Kelsey, you don't want to declare something that then arises those Lazarus species, because it makes it seem like there isn't a problem. But then the flip side, as Lauren was saying, if you have too many hopeful headlines and you don't tell the complete story, I mean, we are in the middle of a mass extinction crisis. So you also have to tell the complete story of lost species, which is some of them are going to be declared extinct. It's the reality. Moving on to the next question, Eric, it's directed at you. When you said it's not feasible to look at the 18K freshwater fishes, do you mean just given the preferred timeline for a lost species project?
Yeah, good clarification there that I should have been a little more clear about. So I meant through the process of compiling the list. So again, with the lost sharks list, because there are only 1,250 or so species, we were able to go through every single species and do an online literature search for each species to compile that list and figure out which ones had been lost or not. For something like freshwater fish, that example with 18,000 species, to actually compile the list, that's much more challenging. You still could do it. You're just going to need a lot more people or a lot more time. So I wasn't really referring to actually going out and trying to find species on a given taxonomic group's lost list, but actually just putting the list together.
All right. If a lost species is found, do you work to put together an SSP, a species survival plan, and keep a stud book? Maybe I can jump in on that. Yeah, we don't want to just find them for the sake of finding them, obviously. So there are a lot of things that we put into place at Rewild. We have a vast team that works on protections, land protection. So they immediately, anything that's rediscovered immediately triggers a key biodiversity area analysis, area for zero extinction. It can trigger the expansion or developments of protected areas and marine protected areas. We also work closely. We have working groups for zoos and aquariums and other institutions, breeding centers, things like that. So yes, it always triggers another layer of conservation. And as Lauren was saying, that paper that she cited, many of these species, if it's not because they're difficult to locate just because of geographical limitations or things like that, they will need some kind of protection. They are critically endangered. They're lost for a reason. So yeah, there always is a follow-up to that. And so are you seeing the impacts on lost species being things happening other than changes in the climate, such as mostly human fishing and things that can be reversed quickly?
Probably varies a lot for which group you're talking about, right? So with sharks, for example, and a lot of fish, overfishing is probably the leading threat to populations of those species. Wasn't sure if you kind of included that in your question, but overfishing is going to affect shark populations much more, at least right now, than climate change or warming sea temperatures, for example. But that would possibly be different in maybe terrestrial species, but I'm not too sure.
I would just quickly add to that and say that a lot of threats are not easily reversible, like climate change or like the chytrid fungus that affected amphibians. But there might be some that could be eradicated, some threats that could be eradicated with education. Like poaching, for example, or trafficking of species. And I'm sure that's not easily eradicated, but threats like that might be more reasonable to eradicate than say climate change or wildlife diseases for which there's no known cure.
How are the maps of lost species created, with records and building minimum convex polygons, or records and building sampling effort rosters in hexagons or other techniques?
In our cases, we are typically using spatial data from the IUCN Red List of Threatened Species. There are, of course, other databases that may be more updated than the Red List. But typically, those data need to be verified by experts, and so we don't use them for now, but they may be fed into the IUCN Red List maps, hopefully in the future, if they are valid records. And so, as I mentioned in my presentation, we've got about 80% of the species on the lost species list that do have spatial data. And so there's going to be 20% that don't. And ideally, one day we will have spatial data for those species, and we can continue to update the maps from there.
Eric, there's a couple here for you. In monitoring the shark species, did you have data on their breeding success too, or did their imperiled hiding pose some possible stress to hinder this? Have you noticed a resurgence in populations of the shark species yet? And then the second one there is, are there many lost sharks where taxonomic uncertainty is also a factor?
Yeah, so I'll start with that second one just because it's a bit quicker. Yeah, it definitely made putting the list together kind of complicated in a few scenarios because occasionally species go through reclassification, or their naming is changed essentially over time based on new information, or maybe it's genetic work. So we did notice that in a couple of cases where we had a couple things on the lost list, but it turns out you just have to dig into it a little bit more and figure out, oh, the name just changed. So that was relatively easy to deal with, but definitely something to look out for. And then for the other question, we weren't specifically looking into any of their sort of reproductive information or their breeding success, as mentioned there. But that does, so we didn't necessarily take that into account putting the list together, but that does play into a lot of how you would approach management or conservation of different species, especially for sharks. So, for example, a lot of deep water species have much sort of slower, they mature later, they have a lower reproductive output, so they're having less babies. And those factors typically make any animal, not just sharks, more susceptible to going extinct, basically if they can't replenish their population as quickly, whereas you have some coastal species that might reproduce after just a couple of years of age, and they have, you know, a handful of pups every year and are a little bit more robust to some of those stressors. So we didn't take that into account when putting the list together, but it's definitely an important factor when you're trying to actually use the list to say, how are we going to best manage or best protect one of these threatened species?
Awesome, thanks. Mark asks, how may we best apply for support, funding, and or press coverage for our lost species searches from Rewild? I put my email address in the chat. I'll put it there again. You can contact me directly. I know, Mark, you reached out about a spider previously, so glad to field those requests. Then also, what are the indicators of lost species and rediscovered species? Kelsey, I think that's asking, could you jump in on that? I think that's asking the definition again, just to clarify.
Yeah, so as far as meeting criteria to become a lost species, the species must be without a scientific documentation for at least 10 years. And again, that can be regardless of whether the species is likely to be extinct or whether or not we just really haven't looked enough for it and need to go out and look for it. The species cannot be held in captivity. So species that are extinct in the wild, but held in captivity won't qualify for a lost species. And as far as being a rediscovery, typically there needs to be on observation of the species, photographic evidence, or otherwise that is verified by experts, and that we're able to confirm that's actually the species.
Yeah, and Lauren, did you want to jump in on rediscoveries as well? Things that you found in your data?
Yeah, I think Kelsey largely covered it. I would just say, as I said, the rediscovered species, a lot of them did tend to be in those like tropical or regions or islands or something, but I think that's just lost species in general, not necessarily specific to rediscovered ones. But I think what Kelsey said largely summed it up. Thanks.
Okay, awesome. And the last thing here in the Q&A from Mauricio just talks about the difficulty in finding lost species, and I can say he's not wrong. They're lost for a reason, and it most often takes many efforts. It's very rare to strike lightning on the first try, and so we see it taking 2 or 3 multiple surveys to find. Obviously, we have a lot of new technologies that we use. We're using eDNA a lot more frequently, almost on all of our searches. Not as proof of not the evidence that we need. We really prefer that photograph or audio or true genetic information, but at least it directs us where to go so that we can use our resources more efficiently. So it's difficult, but it's worth it. I can say you saw in the video that moment when they rediscovered the pheasant pigeon after 126 years, that moment that you know that you're preventing extinction and getting something that has been neglected into a pipeline of conservation is really, truly heartfelt. So thank you again so much for joining us. And also next, we have one more left next week, or 2 weeks from now, October 31st at 9 a.m. We're going to host a panel of citizen scientists. I know there were some questions about iNaturalists and things, so we have a panel of people talking about citizen science and lost species. And thank you to our panelists and everyone who joined us today.